Alright, so here we are with Unit 7, Day 3, Rate of Change from Graphs. Okay, the big difference between today and yesterday when we started with slope is that every one of these problems is going to have some context. Okay, so let's get started. At a department store sale, all merchandise is sold at a certain percentage off of the regular price. The graph below shows the amount of savings at this rate. Determine the rate of change and its meaning. Okay, so the rate of change really just means slope. So first thing we need to do is pick 2 points. Now there are not any that are just given to us, so we need to find perfect points. They need to be on the grid line. So like if that were on the graph, that'd be a perfect point. Okay, so I am going to pick this one right here at 30, 10. And I see another one at 60, 20. Alright, now the rise, we always do rise over run. So the rise is, and we have to pay particular attention to our units here. These are actually going up by tens, so that's up by 10. And our run starts at 30, ends at 60, so plus 30. So rise over run, 10 over 30. Which still as a fraction reduces to 1/3. Okay, and in this context we're actually talking about money, amount saved, and regular prices all in money. So we're gonna say that's approximately 0.33. So my rate of change, I'm gonna put that 0.33, and the meaning here has to do with the amount saved, and this is the amount spent. So this comes out to be $0.33 saved per dollar spent. So 33 cents saved per dollar spent. And that's my context. So that's going to be the meaning. The meaning is going to have to do all with just the context that it's in. Alright. Number 2, cost of cherries. Okay, so if we're looking just at kind of what's here, we have cost and we have pounds of cherries bought. So our meaning is going to have to do with those two things. So first, perfect points. Okay, so 2 and 3. And I see another perfect point right here at 4 and 6. Alright, so the rate of change, we need to look at the rise over the run. So the rise goes from 3 to 6, so that's up by 3. And the run is from 2 to 4, so that's 2. Okay, now usually I like these in improper fractions, so I can say that is 3 over 2. Now when I get to the meaning, however, it's going to end up being, I'm going to write it this way, I get $3 per 2 pounds. $3 per 2 pounds, so that, when you actually figure that out, is $1.50, so 3 over 2 is 1.5. $1.50, that's cost per pound of cherries bought. Okay, and again, it all comes down to that context. So in this case, it is cost of cherries, so the cost per pound, $1.50 per pound. Okay, number 3. You just inspect our graph to begin with. Okay, so we have temperature during the evening. It's temperatures in degrees Fahrenheit versus the hours after sunset. And our graph is going by in ones on the hours and in tens in the temperature. So we'll pick 2 perfect points if we can find them. Let's see here, 3 and 40. And 5, 20. And I'm sure there are others you could pick. So I'm going to see rise over run. The rise is going from 40 to 20. So that is actually falling, negative 20. run goes from 3 hours to 5 hours. So that's 2 hours. So negative 20 over 2. So the rate of change, if I divide that out, is negative 10. Alright, and so as far as our meaning goes, I'm going to say negative 10 degrees Fahrenheit per hour after sunset. Okay, and perhaps more accurately, I could say something like the temperature falls. So the temperature falls 10 degrees Fahrenheit. So I could alternately say the temperature falls 10 degrees Fahrenheit per hour after sunset, because that's what that negative indicates, that it's falling. Alright, so number 4. The function rule is C equals 1/2 B, where C is the amount of sugar used and B is the number of batches of cookies made. Which graph below represents the function if the amount of sugar that would be needed is changed to 1/3 a cup of sugar per batch? Okay, so really what we're really looking for is our graph needs to match this, 1/3 a cup of sugar per batch. So if you think about what that means that one batch needs 1/3 a cup, 2 batches is 2/3 a cup, and 3 batches equals 1 cup. And I'm going to just really look on my graphs for this, okay, on these options. So one batch should be about 1/3 of a cup. Now, if we look at all of our graphs, they have number of cups of sugar needed and number of batches. So for one batch, I said it should be 1/3 of a cup, so that's somewhere in here. 2 batches should be 2/3. 3 batches should be 1. Okay, so A is clearly not it. Same thing here. This is what I know that it should match. So B does not work either. C, we have 1/3, 2/3. Nope, C doesn't work either. 1/3, 2/3, 1. That doesn't match. Looks like this one is pretty close though, so E is the choice that matches. Okay, so I took what they told me, 1/3 a cup of sugar per batch. What does that mean to me? And then I'm just trying to relate it, make sure that it matches. Okay. Alright. Mark and his brother went on a canoe trip. The graph shows the relationship between the distance traveled and the time of day. What was the brothers' average speed in miles per hour from 1 p.m. to 2 p.m.? Okay, so I'm going to look, here's 1 and 2, so they were going 5 miles an hour at 1 p.m. Let's see, 6, 7, 8 miles an hour. Okay, so 8 miles an hour at 2 p.m. So the rise in speed there was from 5 to 8, so up 3, and that was in 1 hour, so that would be 3 miles per hour, which actually, by the way, mph, miles per hour, literally means they went 3 miles in 1 hour, 3 miles per hour. So that is B. Okay, now during what time periods are the brothers resting? Okay, well, resting means they're going 0 miles per hour. They're not going anywhere. And so yesterday, I'm going to tie this back into here. We have Hoy, Bucks, horizontal, 0 slope. Vertical is undefined slope. So we want the 0 slope, 0 miles an hour. So we want the horizontal segments. So we've got a segment right here from 2 to, I guess that's like 230. So from 2, no, more like 330 2 to 3:30 p.m. And we have another horizontal segment from, looks like just after 5 to 6, so let's just say 5 to 6 p.m. So they were resting between those hours. Okay, and now we have number 7. Which of the following graphs has a positive slope? Okay, now the one thing I want to make sure you all take away from this is that positive slope looks like a positive correlation. Okay, they always go up and to the right. So positive is up and to the right. A negative slope goes down and to the right. A zero slope is a horizontal line. And the undefined is a vertical line. So this one is undefined, this one is negative, this one is a zero slope, and this one is positive. Okay, which of the following graphs represents a truck that gets 16 miles per gallon of gas? 16 miles per gallon. Okay, so again, I'm going to take that to mean that in 1 gallon, so if they use 1 gallon, it means they get 16 miles out of it. If they have 2 gallons, that means they get 32 miles out of it. Okay, so 1 gallon should be somewhere around 16. 2 should be somewhere around 32. 1 should be around 16. 2 should be 32. 1 should be 16. 2 should be 32 somewhere. So B is quite obviously the one that has that slope. Okay, very similar thought process for these next few. The following represents cheese that sells for $4 per pound. So well, that means, for 1 pound, it's $4. For 2 pounds, it's $8. Okay, so 2 pounds should be $8. So that should be right there. 2 pounds should be $8. 2 pounds should be $8, and the only one that matches closely at all is B. Which graph represents the cost of bananas when $2 will purchase 5 pounds? So our graphs, if I notice, they all have amount in dollars and pounds down here. So 5 pounds, that's in the x-axis. So really I'm looking for this point right here. 5 pounds is $2. 5, 2, 5, 2, 5, 2. C matches just fine. Alright. As we go, we need to remember one fact, and that is slope means the rate of change. Okay, so it has to do with how fast the y is changing, the dependent variable, how fast the dependent or the y is changing compared to the x. Okay, so it's a rate of how fast y is changing. So if we look at number 11, 4 runners are competing in a marathon. The graph below shows the distance run by each runner after 1 hour. Which runner ran at the slowest rate? Okay. Well, before we said slope is the real definition of that is the steepness of a line. Okay, so the greater the steepness, the larger the slope. So if I want the slowest rate, I want the least steep slope. So that is going to be runner D. If, however, they had said the fastest rate, which one of these is the steepest line? Well, that will be runner A. So we have to pay attention to what they're asking. They gave us that it said they wanted the slowest rate, so we had to know which one we were looking at. Okay. 12. Which one of these situations is best modeled by the graph below? The bowling alley charges $2 per game plus $3 for a pair of shoes. Okay, now the thing to notice here is that the pair of shoes is actually paid for once. Okay, so it's the starting place on our graph. It should be the starting place. So if I look up here, it's starting at 3. Okay, so that actually could make sense. This is per. The word per tells you that's where your slope's going to be. $2 per game. So the slope on this one is saying the slope is 2. Okay, down here, tickets cost $3 each. That tells the slope is 3 each, so it's 3, plus a $2 service charge. You pay the service charge once, so this is the starting place. Okay, CDs are on sale for $2 each. There's our slope. It's $2. Or a hiker hikes at a rate of 3 miles per hour. There's our slope. Okay. Slope is always a rate, so per, each. Those are things that tell you. Those are things that tell you what the slope is, what part of this is actually changing. Okay, so if I were to pick 2 points, it looks like that's about 3. I'm going to try to do my best. I don't think there are any perfect points. Well, there's one perfect point right here, 6. 6, and I guess that's 16. Yep, I think that might be the only perfect point. So we're going to say from 3 to 16, I guess we said that is, over the course of 6. 6, 16, something like 13. Okay, so that's 2 point something, okay, as the slope. So that's definitely closer to these two right here. The slope was 3. Slope was 3. Now it may be that point isn't exact, and that's why. So I'm kind of estimating here. Okay, so I bet the slope really is actually 2. I'm just not seeing that, so my points aren't lining up that way. But it's definitely closer to 2. Now we look at the starting place. So this one, the starting place. If you bought 0 CDs, that ought to cost. Okay. If you bought 0 CDs, that ought to cost nothing. So if it were this one, it would actually be starting right there at the origin. So this one starts at 3 for the pair of shoes. Okay, 13. The graph below shows the cost, C in dollars, of going out on a fishing boat for H hours. Which of the following best describes the meaning of the slope of the line in the situation? So slope is rate of change. Okay, so it has to do with how much something's changing. So there are some key words we see in these. This one is each additional hour. Each additional hour. That says something's changing. This, however, flat fee, that's not changing. Slope has to be something that's changing. So it's one of those two. Now it's just a matter of picking 2 good points on this graph and figuring out the slope. So it looks like 260 is a good perfect point. And they're at 120, so 620 is another perfect point. So the rise is from 60 to 120. And the run is from 2 or 6, so that is from 2 to 6, that's 4. So rise over run is 15. So $15 per hour, which is F. So 14 on the graph below, C represents the cost in dollars of renting a motorboat for H hours. Okay, so again, what does the slope of the graph represent? We're all about slope here. Okay, so that is something changing. So the slope is the rate of change. In this case, it's going to be the cost per hour, how much the cost is changing. So flat fee, those two are out. Got to know what you're looking for. In this case, slope, got to pay real close attention to that vocabulary, cuts out a couple of those. Now I just need to find the slope. So 2, 100 is a point there. 6, 200 is a point there. So the rise is up 100. And the run is from 2 to 6, so it's plus 4. So 100 over 4, the rise or run. So $25 per hour, which lines up very well with H. Okay, 15. Which real-world situation is best represented by the graph below? Okay, so first thing, since we have been talking about slope, is we need to look for the slope words in here. So a sheep weighed 3 pounds at birth and gained 2 pounds every week. There's our slope right there. A water tank is filled at a rate of 3 gallons per second. There's our slope right there. A student had $2 in his wallet, that's a starting place, and added $3 per week. There's our slope, is 3. And every question on the test is worth 2 points. That actually, even though it doesn't look like it, that is a slope. So let's see if we can figure out the slope up here. Looks like it's starting at 2, 0 and 2, and then 2 and 8. That's another point there. So the rise, since we always want to figure that out, rise over run, so the rise is 6. It's going up, so plus 6, and the run is 2. So rise over run is 3. So the slope is 3. That cuts A out. Okay, keeps B, that keeps C, cuts D out. Okay, so what's going to make the difference here is the starting point. Okay, so the starting point was actually $2 right there. This one, if you haven't gone any seconds, there's no time that's passed. If it's filling at 3 gallons per second, that means that this one will be empty then, so it'll actually be starting at origin. So this one starts at $2 right there. So C is it. Alright, last we have 16. Alright, now if you notice there are no grid lines on here. The grid lines are faded out, so I am going to just kind of sketch a few of those back, and you can, if you look closely, you can tell where they were supposed to be. Okay. Alright, so the graph below, C represents the cost in dollars of renting a moving truck for H hours. What does the slope of the graph represent? Alright, so immediately I can throw out a couple of these. Which ones? Yep, C and D. Flat fee does not work. So it's either going to be these two. Each additional hours, each tells that is a slope description. So 2 points. So let's say 3 and 100. And 5 and 140. So we're going from 100 to 140. So from 100 to 140 is going up by 40. And the run is going from 3 hours to 5 hours. So 2. Rise over run, 40 over 2. 20, in this case $20 per hour, which lines up with A.